Good morning, student. Today we are going to see a new topic, evaporation. We know that liquid get converted in the form of gaseous state at a constant temperature by absorbing heat. The process is called as vaporization. But another process is there which converts liquid into a gaseous form at all temperature, not at a fixed temperature, and that is known as evaporation. So let's start evaporation. New concept. What is this evaporation? It is a process of converting liquid into gases, converting liquid into gases at all temperature, by absorbing heat. Okay, that is known as what? Evaporation. Now, I told you a vaporization. What is vaporization? Vaporization is a process. It is also a process of converting liquid into gases at fixed temperature. This is important. Okay? By absorbing heat. So main difference. This happens at a fixed temperature. This happens at all temperature. Okay? This is the main difference between evaporation and vaporization. So let's see the question. Differentiate between evaporation and vaporization. Let's see answer. There are 4 differentiating points in evaporation and vaporization. Okay, first one is that this evaporation takes place at all temperature. Okay, evaporation over. First one. Second, vaporization takes place at constant temperature. This is the first one difference that I just told. Next, evaporation is a slow process. It is slow process. It's called time लगता है. Okay? Evaporation is a slow process, while vaporization is a fast process. Okay? This evaporation takes place only at surface of liquid. लिक्विड के सरफेस के ऊपर ही ये इवेपोरेशन होता है, सरफेस ऑफ लिक्विड. But this vaporization takes place. It takes place throughout liquid. Throughout यानी पूरे पानी में. Throughout liquid. पूरे liquid में ये होता है लिक्विड के सरफेस फेनोमेनन. Okay? Evaporation have a cooling effect. It has cooling effect. इसको cooling effect होता है, यानी सराउंडिंग को जो है वो कूल कर देता है. It has a cooling effect, but vaporization does not produce cooling. It has no cooling effect. So these are the differentiating points between the vaporization and evaporation that you have to keep in mind. Next question. State factors on which evaporation depends. State factors on which evaporation depends. Explain how. Explain how. How it depends. I can answer first. There are 5 major factors on which this evaporation takes place. First is the temperature of liquid. First factor is temperature of liquid. Okay. A wet cloth dries up faster on a hot day than on a cool day. जिस दिन hot day होता है उस दिन wet cloth जल्दी dry हो जाते हैं, but अगर वो cool day रहा तो it require a lot time. इसका मतलब हो गया, if the temperature of the liquid is more, temperature of liquid if increases, okay, then evaporation also, rate of evaporation also increases. This is the first part. Second, area of exposed, okay, area of exposed surface. Surface area आपने कितना फैलाया हुआ है, एक्सपोज किया हुआ है. ओके, सो एज एरिया ऑफ एक्सपोज सरफेस increases, then evaporation also increases. Okay, because of that, when we spread up the cloth, those clothes will get dried up faster than the clothes which are folded one. Third, nature of the liquid. Nature of liquid. If it is a water, then it requires a lot of time. But some liquids are there, like as alcohol, spirit, which get evaporate faster, or petrol. If you take a petrol on your hand, then you find cooling effect as well as it get evaporated faster. So nature of the liquid is also there. If liquid is volatile, volatile उसको बोलते हैं जो जल्दी evaporate हो जाता है. So liquid is volatile. If liquid is volatile, then rate of evaporation is more. Rate of evaporation ज़्यादा. For example, volatile liquids कौन से होंगे? Volatile liquids, petrol, alcohol, spirit. This will get evaporate faster than other liquids. Fourth point is flow of air above liquid. लिक्विड के ऊपर बहने वाली जो हवा है उसका फ्लो अगर ज्यादा है तो इवेपोरेशन हो जाता है. सो वी कैन से दैट इफ फ्लो ऑफ एयर above liquid increases, then rate of evaporation also increases. Okay. Fifth point, presence of humidity. Humidity means what? Humidity means presence of water. पानी की मात्रा हवा में होना ये है presence of water in air. Okay. So if humidity increases, then the rate of evaporation decreases. We know that during the humid day, cloth required more time to dry up. But if a dry day, then we find that the cloth requires lesser time to dry up. Okay? So these are the factors on which the evaporation rate depends. Okay? Next. Evaporation on molecular theory. Okay, let's see what molecular theory tells us about the evaporation. Evaporation के बारे में molecular theory हमें क्या बताती है? Assume that in a container there is a liquid. Say this as liquid. Molecules can travel in the liquid at most up to the surface. Okay? Now what happens over here? These molecules which are at the surface of the liquid absorb heat, or we can say energy, from surrounding. Okay? It absorbs the heat from the surrounding. As they absorb the heat from the surrounding, the kinetic energy of this molecule increases. And as the kinetic energy of these molecules, which is at the surface of the liquid, increases, then the space between this molecule increases. Means force of the attraction between this molecule, this force of attraction between the molecule decreases. Force of attraction decreases, space between them increases, space बढ़ जाती है, attraction force कम हो जाता है, because they become more kinetic. Okay, they get a more kinetic energy. So these molecules which are at the surface of the liquid, they try to leave the surface of the liquid, or they blow with air. Blow with air means this water molecule start blowing with air. Air के साथ बहने लग जाते हैं. So the molecular theory says that the heat energy gained by the surface molecule of the liquid and kinetic energy of these molecules get increased. Due to that, the force of attraction between these molecules decreases. Intermolecular space between the two molecules increases. Because of that, binding is loose. As this force of binding becomes loose, these molecules easily get right on the air and they can blow away. निकल जाएंगे एयर के साथ. This process is very slow process. It happens at all temperature. Okay, and it is a surface phenomenon. That only I told you in the differences also. It is a surface phenomenon. So this kinetic theory tells us how the evaporation happens over here. This is a slow process, but here you can see that whatever the rain we are getting on the earth, okay, this is only due to this evaporation. Sea water which is open get heat energy from the sun, and the surface molecules of the water in a sea get exerted. Means their kinetic energy increases. Due to the increase in kinetic energy, they become more excited. As they become excited, they try to break their force of attraction. And the intermolecular space between these molecules increases. They leave each other. As they leave, then they can easily blow up with air. Air ke saath. Because of that, we know this near the sea or at the seashore, there is a humidity or more humid air. Because the water molecules on the surface of this liquid get dried out due to this process, evaporation. So water get converted in the form of gases and they get collected in the form of cloud. They reaches to the every area of our India, and then we are getting the rain. So this is a very important concept in the physics known as evaporation. Okay, remaining topic we will see tomorrow in the next period, and after every chapter I am going to keep your live session on the Zoom app. So I request you all to download Zoom app. I send you a link and then we together discuss this chapter. If you have any doubt, then you can ask me and I will answer you. Alright? Thank you. One more period required to complete this chapter, means possibly on Tuesday. That is our period. So on Tuesday I will send you a video, but after Tuesday, say Wednesday or then on the Friday, if our period is there, then I will keep your online session and we will do whole discussion. Wherever you are finding the problems, that you search out, pick it, write it on the page, and at that day you ask me. I will answer you. Okay? Thank you.